Hey guys, this looks like a fun one. It's the nth root of the quantity negative 12 over the quantity 4 to the power of the quantity n plus 1 minus 2 to the power of the quantity 2n plus 4. In order to solve this one, I'm going to use all of these notes. And if you want to try it on your own, pause it right now because I'm going to solve it in 3, 2, 1. First thing I'm noticing that if we use these notes right here, we can rewrite this and we can rewrite this. So it's a to the b plus c is equal to a to the b times a to the c. So the base gets rewritten, and then this goes in this exponent, and this goes in this exponent. So for 4 to the power of n plus 1, we're going to write down the base twice, and the n will go in this exponent, and the 1 will go in this exponent. And then for the 2 to the power of 2n plus 4, we're going to write the base 2 twice. This 2n will go here, and the 4 is going to go there. And let's clean this up and let's put these into here. For the 4 to the power of n plus 1, we're going to put 4 to the n times 4 to the 1. And then we're going to subtract. And for this one, we're going to put in 2 to the power of 2n times 2 to the 4. And now we can clean this up. 4 to the first power is equal to 4, and 2 to the fourth power is equal to 16. And then using these notes, we can rewrite the 2 to the power of 2n. Anytime you have a to the power of b times c, that's the same thing as a to the power of b, whole thing to the c. So for 2 to the power of 2n, we're going to do 2 to the 2, whole thing to the n. So we can change this into that. And then from here, inside of the parentheses, 2 squared is equal to 4. And now we can smush everything together, and each of these terms contains a 4 to the power of n. So let's copy this down here and factor out 4 to the power of n. For the first term, after you factor out a 4 to the n, we're left with 4. And then we're going to subtract from that 4 to the power of n taken out of this term, which leaves us with 16. Inside of the parentheses, 4 minus 16 is equal to negative 12. And then this negative 12 on top and this negative 12 on bottom can cancel each other out. So we're left with the nth root of 1 over 4 to the power of n. And then using these notes, anytime you have a radical of a fraction, you can split it to the top and bottom. So the nth root of 1 over 4 to the n is equal to the nth root of 1 over the nth root of 4 to the n. The nth root of 1 is equal to 1, and then on bottom for the nth root of 4 to the nth power, this radical and this exponent are going to cancel each other out. So we're left with 1 over 4. And this is the answer to our question. Let's put a box around it. All of this simplifies to 1/4. And that should be true for all real values of n. Maybe. Actually, there might be an excluded value. We got to make sure that this in the denominator cannot be 0. If we simplify this, it'll tell us if there's any excluded values for n. First, let's add this term to both sides. On the left-hand side, this will all cancel out. And on the right-hand side, we'll be left with 2 to the power of 2n plus 4. Let's smush everything together and see what we can do from here. Let's rewrite this 4 as 2 squared. And then using these notes, we know this 2 exponent will distribute to each of these. So the left side will end up being 2 to the power of 2n plus 2. And then we can copy down the right-hand side. Now from here, we can use these notes to expand this again, giving us 2 to the power of 2n times 2 squared can't equal 2 to the power of 2n times 2 to the 4th. Let's divide both sides of this inequality by 2 to the power of 2n. On the left-hand side, these are going to cancel, and on the right-hand side, these are going to cancel. So we end up with 2 squared cannot equal 2 to the 4th. Well, that ends up being 4 cannot equal 16. This will never be false, so that means n is going to be true for all real values. So 1/4 is this fully simplified, and there's no restriction on n. How exciting.